Hello everyone, I am Sneha, Assistant Professor, Department of ECE, Siddhartha Academy of Higher Education, deemed to be University. Let us discuss about classes and objects. So in Python, as Python is a object oriented programming language, which means that it provides features that support object oriented programming. It has its roots in 1960s, but it wasn't until the mid 1990s that it became the main programming used in the creation of new software. It was developed as a way to handle the rapidly increasing size and complexity of software systems and to make it easier to modify these large and complex systems over time. Up to this point, we have been writing programs using a procedural programming. In procedural programming, the focus is on writing functions or procedures which operate on data. In object oriented programming, the focus is on the creation of objects which contains both data and functionality together. So let us have an overview of object oriented programming. First one is class. A class is a conceptual template or blueprint that defines the structure and behavior of objects. It encapsulates data and methods to represent real world entities or abstract concepts in programming. Classes allow us to create multiple similar objects efficiently with shared behaviors and attributes. Coming to next one, class variable. A class variable is a variable shared across all instances of a class. It's defined within the class body but outside any methods. This variable is not tied to a particular object's state, rather it represents data that's common to all instances of the class. Changes to a class variable affect the objects of all classes. Next one, data member. A data member is a variable defined within a class that holds data associated with that class and its objects. These members represent the properties or attributes of a class. They can be class variables or instance variables. Next one, function overloading. It refers to defining multiple functions with the same name but different types of or numbers of parameters. This allows functions to handle different types of input or perform slightly different operations while maintaining a common name, improving readability and reusability. Next one, instance variable. An instance variable is a variable defined within a method of a class and is unique to each instance of the class. It represents the state of an individual object and differs from object to object even though they belong to the same class. Next one is inheritance. Inheritance is a mechanism by which one class can acquire the properties and behaviors of another class. It promotes reusability and allows new classes to be created with minimal code duplication. Next one, instance. An instance is a concrete individual object created from a class. It contains specific data and can perform actions defined in the class. Each instance can have different values for its instance variables even though they share the same structure. Next one is instantiation. It is a process of creating an actual object from a class. It is the step that turns a class blueprint into a usable concrete entity in memory. Next one, method. A method is a function defined within a class. It represents behavior or actions that objects of the class can perform. Methods can operate on the object's data and define the object's capabilities. Object. An object is a unique instance of a class. It represents a specific entity that has its own identity, state, and behaviors. An object is a real-world manifestation of a class in a running program. Next one, operator overloading. Operator overloading is a process of defining multiple behaviors for an operator based on the data types of the operands involved. It allows operators to work with user-defined types in a natural and intuitive way. Next, coming to class definition, the statement class in Python is used to define a new class. This creates a template for objects, a sort of blueprint that describes what data and behaviors will the objects will have. So as you see, you can see a sample program on the screen. Here a class employee class, we have created a class employee, and employee count is equal to 0. Here employee is a class, employee is a class. Employee count is a class variable shared among all instances of employee. Every employee object will have access to employee count, and any changes to it will be reflected for all objects. Next, you can see define init of self, name and salary. So this method init, we are talking about init. This method is automatically called whenever a new object of the class is created. It's also known as the constructor or initializer. The purpose of this init method is it is used to initialize the object's attributes with default or provided values. For example, here we have taken init of self, name, salary. Next, self dot name is equal to name, self dot salary is equal to salary. Here self refers to the instance of being created. Name and salary are instance variables initialized for this specific object. Next, calling methods and self. In Python, when you define methods within a class, the first parameter is always self. Why are we using self? Because Python uses self to refer to the current instance of a class. It's a way to access its own data. So for this example is given here, a define display count of self, print employee. So here display count is a method belonging to the employee class. When you call this method on an instance, Python automatically passes the instance as a first argument, which is nothing but self. So you don't need to pass it explicitly. Okay, next is employee count. A class variable, it is a employee count is a class variable shared by all instances, accessed as employee dot emp count from inside or outside the class. So the first method init, it is called automatically when a new object is created. It initializes the object's attributes. Then other methods are defined like regular functions but with self as a first argument. Self is added to Python automatically. You don't need to provide it when calling the method. Creating objects. This section explains how to create instances or objects of a class. So to create instance of a class, you call the class using its name and pass in arguments required by its init method. So each time you create an object, Python runs the init method inside the class, initializing the attributes within the given values. Okay. See the second one, this would create first object of employee class. Employee 1 is equal to employee of Zara and 200. We have taken an example pair. So here employee 1 is an object of the employee class. Zara is passed as an argument, likely the name of the employee. 2000 is passed as another argument, probably as a salary. So these values are stored in the object's attributes. So third one, this would create second object of the employee class. Employee 2 is equal to employee of money, comma 5000. Here employee 2 is another instance of the employee class. Money and 5000 are passed as arguments, storing these values in employee 2's attributes. Accessing attributes. So now that objects are created, let's see how their attributes can be accessed. You access the object's attributes using dot operator. This means you use the object's name followed by a dot and then the attribute or method you want to access. Class variables can be accessed using the class name itself. Class variables are shared across all instances of the class. You refer them using the class name. So there are examples. There is an example given on the screen using the dot operator. Employee 1 dot display employee, employee 2 dot display employee. So display employee is likely a method inside the employee class. When you call it on employee 1 and employee 2, it displays their respective details. So print, you can see the print statement in the last line of the slide. So print total employee percentage D employee dot employee count. So EMP count seems to be a class level variable. It is not an individual object. So using employee dot emp count, it accesses and prints the total number of employees created. So next here you can see an example on the screen. There we have created a class student. So this defines a new class named student, which will serve as blueprint for creating student objects. Next, number grade is equal to 5. This is a class variable shared among all instances of the student class. Since num underscore grades is not prefixed with self, it belongs to the class itself rather than any individual student. It holds the value 5, indicating that each student object will have 5 grades. Again, init method. This method is a constructor, meaning it is automatically executed whenever a new object of the student class is created. Self represents the instance being created. Name is an argument passed to the constructor when a new student object is created. In the next line, you can see self.name is equal to name. It is an instance variable, meaning each student object will have its own unique name attribute. It stores the value passed when the object was created. Next line, you can see self.grades is equal to an empty list. It creates an empty list to store the grades. Since self.grades is an instance variable, each student will have their own separate list of grades. Next, after the next line, you can see a for loop. So here each iteration appends a 0 to self.grades, initializing a list of 5 grades set to 0. Next, you can see an example program on the screen. There we have created a class numbers. It defines a class named numbers. A class is a blueprint for creating objects. Next is a multiplier is equal to none, which means that line represents a class variable. Multiplier is defined and set to none. It's not used in this snippet, but it is a part of the class. Next line, we have used a init method. This is a constructor of the class. It is called when an instance of the class is created. It takes 3 parameters: self, x and y. Self refers to the instance being created. Next, self.x is equal to x. Value of x provided during object creation is assigned to the instance variable self.x. Next, self.y is equal to y. Value of y is assigned to the instance variable self.y. Next line, define add of self. It defines a method add for the class. This method will be used to add the two instance variables self.x and self.y. Return of self.x plus self.y. The add method returns the sum of self.x and self.y. X is equal to int of input of, it reads first number from the user input and converts it to an integer. This is stored in variable x. Next, y is equal to int of input. It reads a second number from the user input and converts it to an integer. This is stored in the variable y. Next, n is equal to numbers of x comma y. It creates instance of n of class numbers using the input values x and y. Print. It calls add method to the of the instance n. Next, built-in class attributes. Python provides several built-in attributes for every class which can be accessed using dot operator. An example, you can see a dict. This attribute stores a dictionary containing the class namespace. It holds all the attributes and methods defined in the class. Doc. This attribute contains the class documentation string. If no documentation is provided, it returns none. Next, name. This attribute represents the name of the class. It returns the class name as a string. Next, module. This attribute indicates the module in which the class is defined. If the class is defined in an interactive session, it returns main. Next, bases. This attribute holds a tuple containing the base classes of the class. If the class does not inherit from another class, it returns an empty tuple. Here is an example, a very lengthy example, in fact, lengthy program. First line is class employee. It defines a new class named employee. This class serves as a blueprint for creating employee objects. Next, class doc string. Common base class for all employees. This is a doc string which provides a description of the class. It helps document the purpose of the class. Employee count is equal to 0. If employee count is a class variable, meaning it is shared among all instances of the employee class. It keeps track of the total number of employees created. Next, init method, as I have already said in this PPT many times about the init method. It is a constructor method which is automatically executed when a new object of the employee class is created. Self represents the instance being created. Name and salary are parameters that will be assigned to instance variables. Next, self dot name is equal to name and self dot salary is equal to salary. Both line stores employee name and employee salary respectively. Each instance of the employee will have its own unique values for these attributes. Next, employee is dot emp count plus is equal to 1. It plus is equal to 1 means it that value will be incremented by 1. It increments the class variable by 1 each time a new employee instance is created. This keeps track of the total number of employees. Method to display employee count. Display count of self print total employee. It defines a method display count that prints the total number of employees. Uses a class variable emp count to display the count. Method to display employee details. Next, define display employee. That regarding that line, it defines a method display employee that prints the name and salary of the employee. Uses instance variables self.name and self.salary. Next line, employee 1 is equal to employee of Zara and that one, and employee 2 is equal to employee of money and of 5,000. Creates two instances of the employee class. Employee 1 with name Zara and salary 2,000. Employee 2 with name money and salary 5,000. And you can see some print statements. Employee dot doc, that line prints the class doc string. Next, employee dot name, that line prints the name of the class. Next, employee dot module prints the module where the class is defined. Next, employee dot bases prints a tuple of base classes. Next, employee dot dict prints the dictionary containing the class namespace.